Let's move on to the next part. Here, we studied the physical properties of our Pre-dispersed products, focusing specifically on how the additives within them impact end applications. This slide shows the results of our PP spinning trials using Pre-dispersed Blue 15:3. We adjusted the pigment addition ratio to evaluate the effect of its additives on the strength and toughness of the textile. In theory, the presence of more incompatible substances would lead to a worse elongation at break in the textile. However, our experimental results found that as the addition level of our Pre-dispersed product increased, the elongation at break actually improved. This indicates that the additives within it have good compatibility with PP fiber. In the case of PA fiber, no conventional wax is compatible with PA. Furthermore, excessive wax can lead to serious migration issues, as shown in this diagram. This creates a significant dilemma for PA fiber. On one hand, without a suitable wax added in sufficient quantity, it's impossible to solve the pigment dispersion problem. On the other hand, using an unsuitable wax or adding too much can lead to a decline in physical properties and spinability. Our pre-dispersed pigment addresses both sides of this problem, perfectly resolving these problems. Additionally, we are currently the only supplier on the market that can provide a PA/PET series of pre-dispersed pigments. Printed films are another common application scenario. Low molecular weight additives tend to migrate to the surface of the product, causing printing ink to peel off. We conducted a series of tests which proved that the additives in Pre-dispersed do not affect the printing results. Okay, let's wrap up by sharing some insights we've gathered from testing organic pigments in our lab. Have you ever run into this situation? A pigment fails in the lab tests but ends up meeting the standard once it's used in actual production? It's frustrating not knowing why. Well, often it's because production equipment delivers stronger shear force than lab machinery. That extra shear during processing usually leads to better pigment dispersion. This highlights a real challenge in the lab. Due to equipment limitations, test results for some hard-to-disperse pigments can be misleading, what we call a deception zone. Take a look at this curve graph. The x-axis represents shear force, and the y-axis represents FPV. The red line represents a pigment with higher pressure resistance. In other words, it has poorer dispersibility. The blue line, on the other hand, represents a pigment with better dispersibility. Now, if the lab equipment can't provide sufficient shear force, users might think the blue line pigment actually disperses worse. But in reality, the opposite is true. Once it's in production, that pigment's FPV performance far surpasses the others. This experiment shows that promoting Pre-dispersed requires close cooperation from customers. We often see clients testing Pre-dispersed with outdated methods and getting poor results. The granular form of Pre-dispersed isn't meant to be tested with 2-roll mills or small injectors. It needs to be fully melted and blended with resin to achieve complete dispersion. Finally, let's quickly go over our Pre-dispersed product lines. We currently offer PE, PP, PA/PET, and PVC series. The PE series is recommended for master batch production using LDPE, LLDPE, or HDPE, suitable for injection molding, extrusion, films, and similar applications. This series also works well for PP master batch in similar scenarios. The PP series is designed especially for PP spinning customers. They often prefer PP wax as a carrier to avoid affecting end product physical strength, so that's what this line offers. The PA/PET series is mainly used for master batches in PA fiber and polyester fiber, as well as other PA, PET, or PBT applications where high dispersion and eco-friendliness are critical. PVC customers rarely produce or use master batches, most prefer direct coloring with pigments or prep forms. Our PVC series comes in 2 forms, one is the common granular type, and the other is a crushed powder. There's no difference in performance, only in appearance. This gives customers options. The powder melts faster and can be used in smaller proportions, but it may generate some dust. The granular form is the opposite. That's it for the basics of Pre-dispersed. We'll have more videos showing how to use Pre-dispersed in real production and important tips to keep in mind.